In this video, we'll do matrix transpose and its properties. Let's start with example. And let's start with a vector example. So here, let's say here A equal this vector, which is 1, 2, -4. And if you want to take the transpose of this, the column, it become a row. So it's very easy. If you have a row, it will become a column. So here, then A transpose equal, so this column, it will become row 1, 2, -4, 1, 2, -4. And now I want to write C matrix. And of course, you can choose any name of this matrix. You can say D, K, N, or any name. I have choose C, this name. And here the elements of this matrix, let's say 3, 2, 1. I will write 3 by 3 matrix. 5, -6, 0, -2, -3, 4. Then C transpose equal, and you can see here this vector 3 by 1, 3 row, it become 1, 3. So you can see 3, 1 here. We have swapped these, so 3, 1, and here 1, 3. And since here it's 3 by 3, it will remain the same here, 3 by 3 matrix. So let's write it here. And we know if you want to take the transpose of any vector or any matrix, the row, it will become column. So the first row, it will become the first column here. The second row, it will become the second column here. The third row, it will become the third column here. And of course, if you want to choose as a column here, so if you want to compute it as this column, it will be here the first row. The second column, it will become the second row. The third column, it will become the third row. So as you wish. I will choose like this. So the first row, it will become the first column. So 3, 2, 1, 3, 2, 1, 5, -6, 0, 5, -6, 0, -2, -3, 4, -2, -3, 4. As you wish, if you want to compute it as row, it will become column, row, it will become column, row, it will become column, or column, it will become row, column, it will become row, column, it will become row. So as you wish to compute the transpose, which is very easy, 3 by 3. So rows, it's become column, columns, it become rows. So rows, it will become columns, columns, it become rows. Now let's try the properties. First one, the identity here, let's say identity n. If you want to take the transpose, it will remain the same as in. And the zero matrix, if you want to take the transpose of a zero matrix and with size n, here size n, it's mean like here, this size 3. Here, if I write 3, so it will become 3 by 3. If you want to write 5, it will become 5 by 5. So the zero matrix, it will not affect it with transpose, and the same thing with identity. Now let's give you example. First, let's go down a little bit. For example, let identity with size 3 by 3. If I want to take the transpose, so I will write it here 1 0 0 0 1 0 0 0 1. So if I want to take the transpose of this, so this row, it will become here the first column, so 1 0 0, so 1 0 0, so I write it here 1 0 0, and here the second row, it will be the second column, 0 1 0 0 1 0, and the third row, it will become the third column, 0 0 1 0 0 1. So you can see here, it's back to identity with size 3. So the transpose of identity matrix, it will not affect the identity matrix. Now, if I have 0 with size 2, 0 matrix here, if I take the transpose, it will not affect it as well as here. So you can see it here. If I take matrix 0 0 0 0, if I take the transpose, of course, it will not affect it. 0 0, the first row, it will become the first column, so here 0 0, and I will write here 0 0, and the same thing, the second row, it will become the second column, 0 0, and here 0 0, which is 0 matrix with size 2. So here the same thing, the transpose of 0 matrix, it will not affect the 0 matrix. Let's change the color. The second property, if I have transpose of A and the whole thing transpose, it will back to the original matrix, which is A. For example, let A equal 0 1 2 3 4 5. If I told you what is the transpose of A and the whole thing transpose, you will say A, because the transpose of transpose, it will become A. You don't need to write the transpose of this one, then you take the transpose of the transpose. No, immediately you can say this equal to this, 0 1 2 3 4 5. The third property, if I have R multiply here R any scalar, or they called it a number, and the whole thing transpose, you will get R A transpose. And of course here R belong to real number, any number. For example, let A, I will choose the same as this matrix, A equal 0 1 2 3 4 5. and let's say R equal 3. Then let's go down a little bit. So here, if I substitute here R equal 3, so 3 multiplied by A, and the whole thing transpose. So what is the answer of this? You will say this scalar, it will go out here, 3, and the transpose, it will distribute to this matrix, which is here A transpose. Now you have to find the transpose of this A. So 3 transpose of this, so this row, it will become a column. So it will be like this, 0, 1, 2, so 0, 1, 2. And the second row, it will become the second column. So 3, 4, 5, 3, 4, 5. So you can see here this the size of this A 2 by 3, and here it will swap these numbers, so it will become 3, 2. 3 row and 2 column. Now you can insert it, but the important that you have to know that this, the whole thing transpose, it will become like this here. So this 3A and the whole thing transpose, it will become 3 outside, and here it will be A transpose. Let's compute this one. 3 multiplied by 0, which is 0. 3 multiplied by 3, which is 9. 3 multiplied by 1, which is 3. 3 multiplied by 4, which is 12. 3 multiplied by 2, which is 6. 3 multiplied by 5, which is 15. The fourth property, if I have A plus or minus B and the whole thing transpose, it will distribute it here, so it will be A transpose plus minus B transpose. Here I write plus or minus. Either you can use here plus, you have to write here plus. If you write here minus, you have to write here minus. So the transpose, it will distribute it here. Let's give you example. For example, let the same A here, I will speed it up. And let's say B equal 2, -1, 4, 3, 6, -3. And I will choose A plus B. You can choose A minus B, but I have choose here plus. So if they told you what is the transpose of A plus B, you have to say A transpose here, like here, A transpose plus B transpose. So you have to say A transpose plus B transpose, which is here. Let's compute A transpose. The first row, it will become the first column. So here 0, 1, 2, 0, 1, 2, as we did before. 3, 4, 5, and here it will become 3, 4, 5, plus, because here plus, here the same thing. 2, -1, 4, 2, -1, 4. So the first row, it will become the first column. The second row, it will become the second column. 3, 6, -3. 3, 6, -3. Let's compute it. 0 plus 2, which is 2. 3 plus 3, which is 6. 1 plus negative 1, which is 0. 4 plus 6, which is 10. 2 plus 4, which is 6. 5 plus negative 3, which is 2. So that's it here. Let's go a little bit down. The fifth property. Before to write the fifth property, of course you can choose any size of matrices here if you want to add them, and they should be appropriate size to apply this property. So you cannot use this property if you have matrix here 3 by 2 and here this matrix 5 by 2. You cannot add them, so they have to be the same size. As we have done in one of the video before, if you want to add or subtract matrices, it has to be the same size. So you have to choose appropriate size. So if you choose 5 by 5, you have to write here be 5 by 5. Now the fifth property, if you have this matrix A multiplied by B and the whole thing transpose, you have to know that the order of these two matrices, it will change and you have to insert the transpose. So it will be B transpose and here A transpose. So you have to change the order here and you put transpose. And the same thing if you have A multiplied by B multiplied by C and the whole thing transpose, you have to know the answer. It will be C transpose. You have to start with the last one, then B transpose, then A transpose. So here C transpose, B transpose, A transpose. Let's give you example. Let A, I will choose this one. 0, 1, 2, 3, 4, 5. And of course, I cannot choose B as this size because the number of column in A, it has to match the number of row in B. So I will choose another B. And let's say here, -1, 2, 1, 3, 5, -2. So you can see if you want to multiply them. So here, this 2 by 3, and here 3 by 2. This, it has to match with this. So the number of column in A, it has to match the number of row in B. And the result matrix, it will be size 2 by 2. And let's say C equal -2, 1, 3, -1, 3, 0. And if I want to find A, B, and the whole thing transpose, you have to write B transpose A transpose. B transpose A transpose. And we know how to find the transpose of this B. So it will become like this. This row, it will become column, so -1, 3. This row, it will become column, 2, 5. This row, it will become here the third column, 1, -2. And of course, if you don't want to compute it like this, you can compute it like this. So -1, 2, 1, the same here, -1, 2, 1, 3, 5, -2, 3, 5, -2. So it's your ways to find the transpose of a matrix. And here, A transpose, which is this one. So I will write it as like this, because the size here 2, 3, here the size it has to be 3, 2. So this row, it will become column, so 0, 1, 2, 3, 4, 5, 3, 4, 5. So this way how to find the transpose. Now let's compute the result to multiply this matrix by this matrix. And here, of course, since this size 2 by 3, and here size 3 by 2, so this one has to match this one. So the size of this here matrix has to be 2 by 2. So let's write it like this, 2 by 2 here. To find the first element here, you have to multiply the first row by the first column. So -1 multiplied by 0, which is 0, plus 2 multiplied by 1, which is 2, plus 1 multiplied by 2, which is 2, 0 plus 2 plus 2 equal 4. So here I have to write 4. The first row with the second column, I will get this element. So -1 multiplied by 3, which is -3, plus 2 multiplied by 4, which is 8, plus 1 multiplied by 5, which is 5. -3 plus 8 equal 5, plus here 5 equal 10. So here I have to write 10. To find this element, we have to multiply this row by this column. 3 multiplied by 0, which is 0, plus 5 multiplied by 1, which is 5, plus -2 multiplied by 2, which is -4. 0 plus 5 equal 5, plus with negative it will be minus, and here I have to write 4. 5 minus 4, which is 1. So here I have to write 1. 1. To find this element here, I have to multiply this row by this column. 3 multiplied by 3, which is 9, plus 5 multiplied by 4, which is 20, plus -2 multiplied by 5, which is -10. 9 plus 20, which is 29, minus 10, which is 19. So here I have to write 19. So this is how to find A multiplied by B, the whole thing transpose. Let's say here A, B, C as this one, the whole thing transpose, equal. So here I have to write C transpose, B transpose, A transpose. First, I have to compute C transpose. C transpose, so since this one 2 by 3, the transpose will be 3 by 2. So here, it look like this. The first row here, it will become the first column here. So -2, 1, 3, -2, 1, 3, -1, 3, 0, -1, 3, 0. We don't need to compute B transpose A transpose since we have it here. Since this one, I will illustrate, since this one equal to this one. So I will write this one here. So 4, 10, 1, 19. Since this one 3 by 2, here 2 by 2. So the result matrix by multiply this matrix by this one, it will be 3 by 2. So 3 row. So here 3 by 2. Now let's go a little bit down. To find this element here, I have to multiply this row by this column. -2 multiplied by 4, which is -8, plus -1 multiplied by 1, which is -1. So here, -8 plus with negative, it will be -1. So the answer will be -9. So here I have to write -9. To find this element here, I have to multiply this row by this column. -2 multiplied by 10, which is -20, plus -1 multiplied by 19, which is -19. And here, -20 plus -19, which is -39. So here I have to write -39. To find this element here, I have to multiply this row by this column. 1 multiplied by 4, which is 4, plus 3 multiplied by 1, which is 3, 4 plus 3, which is 7. So here I have to write 7. To find this element here, I have to multiply this row by this column. 1 multiplied by 10, which is 10, plus 3 multiplied by 19, which is 57. 10 plus 57, which is 67. So here, 67. To find this element here, I have to multiply this row by this column. 3 multiplied by 4, which is 12, plus 0 multiplied by 1, which is 0, 12 plus 0, which is 12. So here I have to write 12. To find this element here, I have to multiply this row by this column. 3 multiplied by 10, which is 30, plus 0 multiplied by 19, which is 0, 30 plus 0, which is 30. So here I have to write 30. 30. So this way how to find the transpose if you have three matrices like this. Now let's give you example about this. Now let's give you example to make sure that you understand these properties. Find the matrix X, this matrix X, and I will write it in bold, satisfy this 2x and here transpose minus 3, 1, 2, -1, 3, and the whole thing here transpose equal 4, 3, 2, -3. Let's change the color. It's very easy to find this matrix. So here, find the matrix X satisfy this equation. So we want to find this X. And you know, before, if you have any algebraic equation, you have to take the terms on the right side. Here you can see here there is transpose, so you have to distribute it. Then this side you have to move it to the other side, then you will get this X. So it's very simple. So now the first step, we have to distribute this transpose. So here I will distribute it here. So the distribute of the transpose as we have done it here, we have to distribute it as here. So here it will be A transpose, B transpose. So we will use this property. So we have to distribute this transpose to this term first. So 2x transpose and the whole thing transpose minus and the whole thing here transpose. 3, 1, 2, negative 1, 3, and the whole thing transpose equal. I have to write this matrix 4, 3, 2, negative 3. Here I have to write f and only f because from here to here. And we know the property of the scalar, it will go out as we done it in the third property. So the scalar, it will go out. So it will become like this, 2x transpose. I write this and the whole thing here transpose. And here the same thing, the 3 it will go out, and here 1, 2, negative 1, 3, and the whole thing here transpose 4, 3, 2, negative 3. Now we know the transpose matrix, it will back to the original matrix. So here it will become just x as we have done it in the second property. Now here I will write 3, the transpose of this matrix. The first row here, it will become the first column here. So 1, 2, I will write here 1, 2, negative 1, 3, negative 1, 3. So the row, it will become column equal this. Now I want to insert this 3 here. So 2x minus, it will become here 3 multiplied by 1, which is 3. 3 multiplied by negative 1, which is negative 3. 3 multiplied by 2, which is 6. 3 multiplied by 3, which is 9, equal 4, 3, 2, negative 3. Now I will take this side to there. So it will become like this, 2x equal this, 4, 3, 2, negative 3, plus this side, because here minus, it will go the other side here. So it will become like this, 3, negative 3, 6, 9. Let's go a little bit down. So here 2x equal 4 plus 3, which is 7. 3 plus negative 3, which is 0. 2 plus 6, which is 8. Negative 3 plus 9, which is 6. Of course, here I have to write it like this. Therefore, to find this x, I have to divide it by 2 in both sides, so it will be like this. Now we have to multiply each element by half, so half multiplied by 7, which is 7 over 2. Half multiplied by 0, which is 0. Half multiplied by 8, which is 4. Half multiplied by 6, which is 3. That's it. That's it. We have found this x. It's very simple. As algebraic equation, you have to find this. So it's very easy. So we have distribute this transpose And when we have distributed and arrange it, it will become like this. And here it's very simple. We multiply 3 by this matrix, then it will become like this. Then we take this side to the other side, like here. Then we add these matrices here. It will become like this. Then we divide it by 2 in both sides. That's why here half. Then we multiply each element here by half. It will become like this. So in the next video, we'll do a video to use matrix inverse properties and matrix transpose properties with plenty of example to help you understanding these concepts in different scenarios. Feel free to comment below if you have any questions or suggestion about this video. See you in the next video.